This is the anaerobic metabolism clip. If you remember back to the last clip, it was an overview of anaerobic and aerobic metabolism. So for this clip, we're focusing on anaerobic metabolism, so metabolism where ATP is produced without oxygen. So the ATP-PC system is the most rapid method for ATP production. The ATP-CP system provides energy at the onset of exercise and also for high intensity exercise lasting for less than 5 seconds. So if we have a look at these two examples on the slide, this is showing you a men's 100-metre sprint, and if you think athletes at the highest level are running that race in about 10 seconds, so about half of the race is supplied by ATP from the ATP-PC system. And also the high jump, if you think about that, there's a very brief high intensity run up and then a jump. So it's pretty much over and done with within 5 seconds. So the ATP-PC system is very important for something like the high jump. If we have a look at the pathway, which is the simplest pathway, it's really one reaction. What we have is adenosine diphosphate, or ADP, plus the phosphate that's stored in the phosphocreatine gets converted into ATP plus free creatine. Creatine kinase is the enzyme that catalyzes this reaction, and it can go in either order depending on the volume of substrate. I mentioned in an earlier clip that we don't store ATP in the cell. The closest we get to storing ATP in the cell is storing phosphocreatine. So the phosphate bound to the creatine allows us to store that phosphate in the muscle, and that means we can quickly access that phosphate, combine it to ADP to form ATP. So as mentioned on the previous slide, this pathway provides energy in the form of ATP for very short events lasting less than 5 seconds, and also at the very beginning of exercise. PC reformation requires ATP, so we'd be looking at the opposite direction here, and this occurs during recovery from exercise. As we store limited amounts of PC in the muscle, it has become relatively common for athletes involved in activities where they're high intensity brief activities to supplement with creatine monohydrate. What this does is increase the creatine levels in the muscle, and that allows more phosphate to be stored. That means during high intensity exercise lasting for a few seconds that you can potentially provide more ATP. Also, weightlifters have been shown to take creatine over a number of weeks, and it has been shown to increase their ability in weightlifting. There is research to support the fact that creatine supplementation can assist or increase the output of the ATP-PC system. I'm not suggesting for a second that you should go out and supplement with this, but it certainly is done. Now on to glycolysis, which is also an anaerobic pathway, and as I mentioned earlier, it is quite a bit more complex than the ATP-PC system. If you've studied biochemistry before, you would have been expected to memorize the name of every single enzyme in a pathway and also the substrates in the pathway. For this topic, you're not expected to remember all of the enzymes and all of the substrates. I will point out the important aspects that you'd be expected to know on an exam. Remembering back to the introductory work we did on metabolic pathways, these green rectangles represent the substrates. And remember that every arrow represents a chemical reaction, and every chemical reaction requires a specific enzyme. So in terms of glycolysis, glucose is the original substrate for the glycolytic pathway. If we look at this first step, you see that glucose is converted into glucose 6-phosphate. You don't need to remember the name of this product. It is then converted into another product, and so on. you'll see that the pathway splits here into two identical parallel pathways. Basically, glycolysis is the breakdown of glucose into two lactic acid molecules and a net gain of 2 ATP. So when glucose continues through the glycolytic pathway, the net gain for the cell is 2 ATP and 2 lactic acid molecules. What you can see early on is that the cell uses 2 ATP. So at this stage, the cell is in debt to ATP. But further down in the pathway, you see that 2 ATP are produced in this chemical reaction here, and then another 2 in this chemical reaction. So the net gain being 2 ATP. In an earlier clip, we talked about NAD and mentioned that it was an important carrier molecule. What you can see here is the NAD has become reduced, so it's happening twice, and the result is NADH. There's no net gain of NADH for glycolysis because the NADH is used further down in the last step that produces lactic acid. So to summarise, glycolysis is an anaerobic pathway, so it occurs in the cytoplasm of the muscle cell. Remember, our focus here is on exercise and muscle contraction and energy use. The net gain for the cell is 2 ATP and 2 lactic acid molecules. This is just putting the theory on the previous slide into a bit of perspective or applying it to real life situations. If we look at the timing of glycolysis, remember that the ATP-PC system was important in the first 5 seconds of exercise. Glycolysis is very important between 5 seconds and 2 minutes. If we have a look at the timing for the elite races, say the 400-metre race, shown here as a woman's 400-metre race, there is a high level of lactic acid production in races such as this, and that's because glycolysis is predominantly used as the energy system to supply the energy for that race. And we can further see this if we look at some of the world records. I'm not sure if these world records still stand, but certainly they give you an idea of the time it takes for the athletes to run these races. So if we look at the men's records and the women's records, they're around 40 to 50 seconds. So that's certainly within that time period there where anaerobic ATP production is very important, and specifically glycolysis anaerobic ATP production. If we look at the 800-metre race, obviously double the 400, 2 times around the running track, you're looking at a time here of 1 minute 40. And again, that's still within that range where anaerobic energy production is very important. When you think of the 3 systems, the ATP-PC, anaerobic glycolysis, and then aerobic pathways, try not to think of the overlap as on-off switches, but that as one system takes over, the other will decline. So when you go from 0 to 5 seconds, it's heavily ATP-PC system. Then at 5 seconds, glycolysis starts. At 5 seconds, you would still have some ATP-PC system, but glycolysis is the major energy producing pathway up to 2 minutes. It's recommended now that you watch a couple of videos, and these videos are linked to on LMS, and they supplement the slides that we've just gone through. The first one is how does creatine work? And you might have noticed in the clip I found myself saying creatine and also creatinine. Basically they're the same thing, it's just the accent, I guess. And the second one is how glycolysis works. And again, that would put one of those previous slides into an animation form for you. Once you've finished the clip, it's suggested that you attempt the quiz called Anaerobic Metabolism, and when you're comfortable with how much you know in that topic, you could move on to the next clip on aerobic metabolism.